Towering pine and spruce forests drape over rolling hills in Canada's Yukon Territory, and the Yukon River and its winding tributaries carve valleys into the landscape. Winters in this part of Canada's northwest are harsh, but the warm summer months are illuminated by sunlight until midnight. Even further north, however, lies the treeless alpine tundra, where freezing temperatures keep the ground frozen all year. Permafrost is the name given to the icy soil. Only moss, lichen, and shallow-rooted shrubs can thrive in the tundra. Despite the fact that moose outnumber people nearly 2-to-1, the Yukon is a thriving mining industry and 14 First Nations groups that have thrived on the land for thousands of years. They are descendants of the last waves of ancient people who crossed the Bering Land Bridge from what is now Siberia at least 15,000 years ago, before the crossing became flooded at the end of the last glacial period. The last glacial period, also known as the last ice age, began approximately 100,000 years ago. Most of North America was covered in glaciers at the time, but conditions in what is now the Yukon were too dry for glaciers to form. Because most of the world's water was frozen, the sea level was estimated to be up to 500 feet lower than it is today. This revealed the Bering Sea floor, forming Beringia, a passage between Alaska and Siberia. Tens of thousands of years before humans and ancient animals made the journey, and the Yukon became a vibrant home for giant creatures known as megafauna. Woolly mammoths migrated to North America from Europe and Asia, and Ice Age horses from North America may have crossed the land bridge multiple times. The landscape was populated by the ancestors of camels, sloths, lions, hyenas, and many other animals. When these animals died, their bodies most likely decomposed, and whatever was not scavenged became part of the frozen ground. The cool touch of permafrost perfectly preserves nearly everything within it, including DNA. Ancient genes can be extracted easily from bones and soft tissue, and scientists have discovered intact genetic material in soil samples. Because their bones and bodies are so well preserved in permafrost, scientists now know how these animals lived and died. First Nations people have extensive historical knowledge of Ice Age animals and their fossils. Similarly, since the Klondike Gold Rush at the turn of the 20th century, miners have uncovered many massive bones, Ice Age relics that are still being discovered in large numbers at mines and riverbanks today. Permafrost is rapidly thawing and releasing its contents as climate change progresses, creating a gold rush for paleontologists. Here are 5 fascinating discoveries from the Yukon's past. Wolf pup nearly perfectly preserved. Canis lupus is its scientific name. What makes this discovery remarkable? She is the most complete wolf mummy ever discovered. She's basically 100% intact. All that's missing are her eyes, study co-author Julie Meechan, an Iowa paleontologist, said in a press release. What scientists have discovered. A gold miner using a hydraulic water cannon to blast frozen mud discovered an object paleontologists recognized as a treasure in 2016. He discovered a nearly perfect female gray wolf pup that died 57,000 years ago. The Ice Age creature was discovered on the ancestral land of the Trondhuichin people, who named her Jur, wolf in Han. According to a study published in Current Biology, X-rays of her bones and teeth revealed she was just under 7 weeks old when she died. Because she was so well preserved, scientists ruled out starvation or predator attack as possible causes of death. Instead, they concluded that Jur was most likely killed by a den collapse. Further examinations reveal that her diet was primarily composed of fish, implying that she hunted alongside rivers with her mother, as modern wolves do today. According to genetic evidence, Jur had distant relatives in Eurasia and Alaska. Wolves in the Yukon today, on the other hand, have a different genetic signature, implying that Jur's population was eventually wiped out and replaced by another. While burrowing animals from this area have been discovered in similar conditions, such as Arctic ground squirrels and black-footed ferrets, mummified remains of ancient animals in North America are incredibly rare, says Zazula in a statement. Studying this complete wolf pup allows us to reconstruct how this wolf lived during the Ice Age in ways that looking at fossil bones alone would not allow us to do. Jur is on display at Whitehorse's Yukon Beringia Interpretive Center. Bones from a western camel, Camelops hesternus. What makes this discovery remarkable? According to a 2015 study published in Molecular Biology and Evolution, the bones rearranged the Camelidae family tree by providing concrete evidence that the animals were closely related to modern camels rather than llamas. Scientists have discovered that the camel family, Camelidae, originated in North America more than 40 million years ago. Their ancestors eventually separated into camels and llamas. Ancestors of today's dromedary and Bactrian varieties crossed the Bering Land Bridge, while llamas and alpacas migrated to South America. Meanwhile, now extinct western camels, Camelops cisternus, which translates to yesterday's camels in Latin, remained in North America until the Ice Age ended. While the majority of them went south, even as far as Honduras, some went north to Alaska and the Yukon. For many decades, scientists hypothesized that Arctic camels were more closely related to South American llamas and alpacas because C. hesternus bones resembled giant llamas or llamas on steroids, according to paleontologist Grant Zazula, who works for the Yukon Territory. Gold miners in Hunker Creek, about 60 miles from the Alaskan border, discovered a pile of Ice Age-era bones dating back 75 to 125,000 years in 2008. A few unusual specimens turned out to be leg bones from an extinct camel species, the remains of which are rarely found that far north. Researchers were able to extract DNA from the bones because they were so well preserved in cold conditions. The genetic data revealed that Ice Age Western camels diverged from modern camels around 10 million years ago. Camel ancestors migrated across Beringia about 7 million years ago. Western camels in the Arctic most likely moved north from their normal range during a warmer period about 100,000 years ago, before becoming extinct about 10,000 years ago. Teeth of an Arctic hyena. Chasmoporthetes is its scientific name. What makes this discovery remarkable? In the past, over 50,000 bones of Ice Age animals have been discovered in the Old Crow area, and we only have 2 bones or 2 teeth of this hyena, Zazula told the CBC in 2019. It's a very rare animal. It was almost like looking for a needle in a haystack, what scientists have discovered. Most people associate hyenas with the stout and scrappy scavengers that live in African savannas or arid parts of India. The cackling creature's ancestors most likely resembled today's hyenas, but had tall, powerful legs for running fast. Chasmoporthetes evolved more than 5 million years ago in what is now Europe or Asia, and their remains have been discovered all over the world, including Mongolia, Kansas, Mexico, and now the Yukon. A fossilized pair of teeth stored in Ottawa's Canadian Museum of Nature was suspected to be evidence of hyenas living in the ancient Arctic, but a formal analysis was not completed until 2019, when evolutionary biologist Jack Seng, an expert on prehistoric carnivores, examined the teeth in person. He knew within 5 minutes that the molar and premolar belonged to Chasmoporthetes. The fossilized teeth, now housed at the museum, were discovered by scientists in the 1970s near Old Crow. Charlie Thomas, a Gwich'in First Nations elder, was part of the team that discovered them. The teeth are difficult to date because they were discovered in a riverbed rather than their original resting place. Based on the geology of the basin, researchers believe the teeth belong to a hyena that roamed the area between 850,000 and 1.4 million years ago. The ancient Arctic beast, like today's hyenas, had a mouthful of chompers perfectly suited for crushing the bones of its prey, which were most likely ancient caribou, young bison, or even baby mammoths. Researchers believe that other Ice Age predators, such as the short-faced bear and the extinct bone-cracking dog, may have outcompeted Chasmoporthetes for food. Skull of a giant beaver. Castoroidus ohioensis is the scientific name. What makes this discovery remarkable? I think when people see our giant beaver skull, they think, wow, it must have been a saber-toothed cat eating people, Zazula told Yukon News in 2019. No, just pond weeds, I replied. It's almost anticlimactic, you know what I mean? You have this 7-foot-tall animal that only eats pond weeds, and you want it to be more dramatic than that, but it isn't. What scientists discovered: the Ice Age giant beaver appears to be a fierce predator, with a pair of 6-inch incisors jutting from its head. But in reality, one of natural history's largest rodents enjoyed diving for aquatic plants. Castoroides ohioensis was about the size of a modern black bear, measuring 6 feet long and weighing 220 pounds. This massive rodent's tail resembled that of a muskrat more than that of today's paddle-tailed Castor canadensis. However, giant beavers were not dam-building, tree-gnawing ecosystem engineers that beavers in the Arctic are now. In a 2019 scientific report study, researchers examined the chemical signatures of several fossilized bones and teeth discovered in the Yukon and Ohio that were estimated to be 10 to 50,000 years old. These experiments revealed that the prehistoric creature preferred aquatic plants. Basically, the isotopic signature of the food you eat becomes incorporated into your tissues. Heriot-Watt University study author Tessa Plint explained in a 2019 statement, because isotopic ratios remain stable even after the organism's death, we can look at the isotopic signature of fossil material and extract information about what that animal ate, even if that animal lived and died tens of thousands of years ago. To better understand today's climate change, researchers are studying the diets of extinct Ice Age megafauna. These animals thrived in wetter climates before becoming extinct 10,000 years ago as climates became warmer and drier. Smaller beavers, which also lived during the Ice Age and are still gnawing on wood today, may have outcompeted them. It's a really cool analogy for what's happening today in the north, because we see animals moving north, north, north all the time now due to warming conditions, Zazula told Yukon News. This migration occurred 100,000 years ago as well, he added. These animals saw these environments moving northward and followed the environment, ending up in places they probably shouldn't be, like the Yukon, because they evolved in more southern conditions. Bone of a scimitar cat. Homotherium latidens is the scientific name. What makes this discovery remarkable? Because so few scimitar cat fossils have been discovered, scientists hypothesized that only a small population of these fanged felines existed, according to the CBC. This humerus caused them to reconsider what scientists have discovered. A bone was discovered in permafrost on a Dominion Creek mining site near Dawson City in 2011. It belonged to a scimitar cat, not a saber-toothed cat. Scimitar cats have shorter, dagger-shaped canines with serrated edges, as opposed to their famous relatives, whose teeth were typically 7 inches long. Researchers at the University of Copenhagen were able to sequence the bone's entire genome because it was so well preserved in icy permafrost. According to a comparative analysis, the specimen's parents were only distantly related, indicating that the population was large enough to be genetically diverse, more so than modern cat species such as African lions and lynx. Researchers can infer how the ancient creature may have behaved because so much is known about modern human and animal genetics, said study author Thomas Gilbert, an evolutionary genomicist at the University of Copenhagen, in a statement. Their genetic makeup suggests that scimitar-toothed cats are skilled hunters. They most likely had an excellent daytime vision and displayed complex social behaviors, said Michael Westbury, an evolutionary genomicist at the University of Copenhagen, in a statement released in 2020. They had genetic adaptations for strong bones, cardiovascular and respiratory systems, which meant they were well suited for endurance running, he added. Based on this, we believe they hunted in a pack until their prey became exhausted during the daylight hours, using an endurance-based hunting style. The bone is estimated to be more than 47,500 years old because it could not be dated using conventional radiocarbon dating, which can only determine object ages within a certain range. It most likely went extinct around 10,000 years ago, along with other Ice Age animals, including its preferred prey. Woolly mammoths, woolly rhinos, large North American horses all went extinct at the same time, Westbury explained to CBC. If you like this video, then please leave a like and subscribe to our channel for more amazing content. Thanks for watching, and we'll see you in the next one.